Today we're going to talk about congruence in overlapping triangles, section 4.7. Now we've already looked at some triangles that overlap a little bit, but we're going to look at that a little bit more closely in this section. Sorry. Okay, so here are two overlapping triangles. We're going to be looking at triangle AEC and I want to compare that with triangle BDC. Okay, and they do overlap, and what we're going to be looking for when we look at overlapping triangles is parts that are the same, parts they have in common. In this case, both of these angles have a common angle in angle C. So when we can look at overlapping triangles and pick out parts that they have in common, we can use those parts to show congruency. So for example, if I copy, that should have been my red one, sorry, AEC, and if I copy outside CDB, we can see that this angle C and this angle C are congruent because when we put them back together, they're the same angle. Okay, so looking for overlapping parts. And we can use common parts to show congruence. So let's take a look at this drawing. And let's say we have some givens. So given that angle ZXW is congruent to angle YWX, we'll look at those in a minute, and that angle ZWX is congruent to angle YXW. All right, so the first one, ZXW is here, YWX is here. The other piece I'm looking at is ZWX, so I'm going to change colors. So I'm going to do this one in red. ZWX, which is this large angle, and YXW, which is this large angle. All right, let's again take our drawing and do it into two parts. So I'm going to take ZWX outside, and I'm going to take YWX and bring it out. What I want to prove in this one, I should have written that down first, is that ZW is congruent to YX. Okay, so WZX, WYX. So what I want to prove is that this is congruent to this. That's what I'm trying to prove. I'm not matching my colors very well today, am I? So that's my prove. All right, so let's look at the two triangles we have. Back to our original givens. In the green, we were given that ZXW, I'm sorry, this is W. All right, ZXW is congruent to YWX. Then I was shown, go back to my red, that ZWX is congruent to YXW. By common part, WX is congruent to WX using the reflexive property, and now I have two congruent triangles by angle, side, angle. So I've shown that with WX congruent to WX by the reflexive property, I can now show the triangle ZWX is congruent to triangle YXW, and that's angle, side, angle. And then since those two triangles have common parts that are congruent, I can now say that ZW is congruent to YX because parts of congruent triangles are congruent. So again, sometimes drawing the triangles outside of the big picture gives you a better chance to see what's going on. Let's try one more. I'll try and do a better job with my colors. The first thing I need to do is add an X here. I forgot that. So separating overlapping triangles and using those to do a proof. So again, we're going to do the same kind of thing we did before. So the first thing I want to do is put down my givens. So my given is that CA is congruent to CE. And these are these two big sides. It's hard to put a congruent mark on these because if I put it up here, it'll look like CB and CD. So I'm just going to draw them in for now. I'm also given that BA is congruent to DE. So that's this little one and this little one. And I want to prove that BX is congruent to DX. So you can see those are these two lines inside here. This is what I want to prove. So I'm probably going to need to use two small interior triangles to prove congruency. So maybe this one and this one. I already have a side in that. I do need to do some other things to get a congruent triangle here, but that would help me to prove my given, which is my BX and my XD. I don't know that yet, but I'm going towards that. So what I'm going to do is I'm going to first draw those two triangles outside of the picture. So that's A, B, X, D, E. I already have a congruency here, but I do need some other pieces. So one of the things that I'm going to do is I'm going to look at two other triangles. And this is where sometimes it's tricky pulling out what pieces you need. But I am going to look at triangle ABE. I'm going to change colors. So I'm going to pull out ABE and triangle DEA. Okay? So with these two triangles, I've already been given that these big sides are congruent. So let's see. Since these two big sides are congruent, I know that this is an isosceles triangle. Therefore, this angle has to be congruent to this angle. Taking these over to my separate drawings, that's these two angles. I also can prove, and I'm not going to write out the whole proof, we'll do that when we get together. I'm also going to say that AE is congruent to AE. I better use two lines because I've used one line back here already. And my given was that AB is congruent to DE. So I've now proved with using this information, because remember, anything you're given you're going to have to use. I've proven that these two by side angle side are congruent. So let's take a look back at my original drawing. Now I can do some transferring of parts. So if I look at the fact that in my congruent triangles, angle D and angle B are also congruent, so I can put those in here. So I'm getting there. I've got a side and an angle. If I use my vertical angles, I can prove congruency here. And now in my two little triangles, let me transfer my information. I've got angle, angle, side. So now these two triangles are congruent by angle, angle, side. And my final step of proving that BX is congruent to DX is that parts of congruent triangles are also congruent. Read through this once again. See if as you do it you can write the formal proof on your own. So pause the video, rewind, go back through this proof, and write down the proof as I go through it so that you have a nice, neat one written out. This is the most complex we're going to see, but it does necessitate pulling some pieces of these overlapping triangles and pulling them apart. All right, that's it.